Good afternoon, everyone. I am Mr. Toby by name. I will be taking you physics, and the topic that we have here is physical quantities. As you can see written on the board, we have that word. Physical quantities are quantities used to describe physical states. Now, as a physicist, we have a lot of things that we use to communicate to what? A fellow physicist. Now, an engineer, we communicate to a fellow engineer, and everything encompasses what? Measurement. Now, when we're talking about physical quantities, are quantities used to describe a physical state. Now, you want to talk about your depths, you want to talk about a field, you talk about what? The length, the width, the breadth. Everything are what? Called quantities. And quantities, in another word, can be called measurements. Measurement. So you can actually put it there. Physical quantities are measurements used to describe a physical state. So physical state simply means something you can see, touch, and feel. Those are physical states. Now we're going to be going down, breaking it down to what? Classification of physical quantities. Now, physical quantities are classified into various types. We have what? Fundamental and derived quantities. And we also have scalar and vector quantities. We also have scalar and vector quantity. We have fundamental and derived quantity. We also have dimension and dimensionless quantities. Now, you actually say that what from all this classification, we are actually saying quantities. You know that what at the back of your mind that what whenever we have the word quantities, we talk about what? Measurement. Now, we're going to be taking it one after the other. We're going to be considering fundamental and derived quantities. Now, let's move on. From the word fundamental, it means basic, foundation of everything. Now, fundamental quantities are quantities that does not depend on all other quantities. That is, they are called independent quantities. Now, when we have fundamental quantities are independent quantities. They don't depend on all other quantities to exist. Now, we have various types of fundamental quantity examples. We have mass, length, we have time, temperature, etc. and so on. So now we're going to be looking at how these things are fundamental in nature. Meaning that what? They don't depend. In a layman word, you say that what? They don't have formulas. In a layman word, they don't have formulas. They are isolated in nature. you can just a mass. You can't tell me that the mass of a body is equals to a particular formula. They are independent quantity. You don't bring out arithmetic operation, either addition, subtraction, or division to find all these terms. They are independent quantities. Now we are going to be looking at the independent quantities that we have on a tabular form. Quantities, permit me. We are going to be looking at their SI units, and permit me, we are going to be looking at what? Their symbols for representation when you are calculating. Now we are going to be looking at the first one. We have what? Mass. 2, we have what? Length. 3, we have what? Time. 4, we have what? Temperature. 5, we have amount of substance. 6, please, I want you at home or anywhere you are actually watching to write down these things. They are really important. You can't do without them in physics. You can't do without them in physics. Amount of substance, we have luminous intensity. Luminous we also have I have 1, 2, 3, 4, 5, 6. We have magnetic flux, and we have 8 as what? Electric current. These are examples of fundamental quantities, and we're going to be looking at their SI unit one after the other. We have the SI unit for mass as kilogram. Kilogram. This is a standard unit accepted everywhere. And we have the SI unit for length to be what? The SI unit for length to be what? Meters. We have the what? Our time to be what? Seconds. SI unit means what? The standard accepted unit everywhere. So we have the SI unit for temperature to be what? Kelvin. Does that mean that we don't have every other SI unit for them? We have them, but these are the standard one in physics. Amount of substance, we have mole. Luminous intensity, we have candela. For magnetic flux, we have Weber. And the last one, we have what? Ampere. Now, we are going to be looking at their symbols, because whenever a magnitude is given to mass, you can't just write the mass of a body is 5. You have to write 5 kilogram. Now, the kilogram, you don't just write it in a full word. We have symbols for them. That's why I have symbols here. We have kg, we have meters, M, we have seconds, SEC, and we have what? For Kelvin, we have what? K. We have for mole, we have MOL dot. You can see them. We have for candela, we have what? CD. We have for Weber, we have WB. And we have the last one as what? Ampere. A. Now, all these are fundamental quantities. These are fundamental quantities. They are independent quantities. Let me do some recap. I said fundamental quantities are quantities that does not depend on all other quantities. That is, independent quantities. They stand on their own. So we're going to be going to the next one, which is what? Derived quantities. Now, when we talk about derived quantities, we say that what? what? From the classification of physical quantities, we have fundamental and derived quantities. If one is independent, the other one is what? Dependent. So derived quantities are quantities that depend on other quantities for their formation. Now, we are going to be looking at types of examples of derived quantities. We're going to be looking at examples. I'm going to give you 2 examples, and I will want you at home there to sit down and write 5 derived quantities with their basic units. Now, let me give you examples so that we can actually stop. We have what? Number 1, the general one, area. Area is length times breadth. But we can't stop there. We have the basic units of area. From here, you come back, your length is what? Meters. And your breadth is also length. It's just a way of differentiating. It's also length. It's also talking about length. We have meters. So the basic unit becomes meters squared. Same thing to what? Volume. We have what? Length, breadth times height. And the basic unit is what? Meters times meters times meters, which is what? Meters cubed from your indices in math. I want you to actually out there go back, sit tight, and write out those quantities that are derived and write out their basic unit. Let me give you the last one. The last one, let's take velocity. Velocity, we have what? Displacement over time. And the basic unit for that is what? Displacement is in what? Meters. And time is in what? Seconds. Now, from your indices, you have that what? If a denominator is coming up and carrying a power of 1, you have m dot s minus 1. There's a power of 1 here. So when it is coming up, it has, this dot means product. So we have what? S raised to power minus 1. Let me just give you more hints on that. So if we have 1 over x raised to power a, you have that what? When you are bringing it up, that will be what? X raised to power minus a. So you can use that. That's the knowledge of math. Physics and math are the same. So please, if you are running away from math and you think that you will survive better in physics, please, you have actually done a great harm to yourself. So you have to take both of them very serious. So the next class we are going to be looking at scalar and vector quantities. Thank you.